The conservation of mass and energy is related to two really important laws that describe what must happen in all chemical reactions. The first is the law of the conservation of mass, and the second is the law of the conservation of energy. And as a bit of additional information, these two laws are effectively saying the same thing according to Einstein's famous E=mc² equation. So the law of conservation of mass simply states that mass is conserved in a chemical reaction. And this means that the total mass of the reactants in a reaction must be the same as the total mass of the products. The law of the conservation of energy states that energy must be conserved in a chemical reaction. And to put this simply, it means that the total energy in the universe must be the same before and after a chemical reaction. Let's have a look at a quick example of each one. For the conservation of mass, let's take an example of a box containing two gaseous molecules. There are 4 yellow molecules and 4 blue molecules. And if I record the mass of my box, let's, for example, say it's 1.2 grams. Now let's imagine that these molecules react with each other to form 8 molecules with 1 blue and 1 yellow particle. The law of the conservation of mass states that if I weigh my box afterwards, it must have exactly the same mass as we started off with. And to make sense of this, we can consider that although the particles have rearranged into different molecules, there's actually exactly the same number of particles in my products as there were in the reactants. And this is true of all chemical reactions. Secondly, let's look at the conservation of energy. In order to understand this, we first need to take a simplified view of the universe. And as a chemist, we're going to break it down into 2 bits, the system and the surroundings. Very simply, the system is the chemicals involved in and produced by the chemical reaction. And the surroundings is effectively everything else. To put this into context, let's imagine that I've got 2 chemicals reacting together in a beaker. The conservation of energy means that if my chemical reaction is releasing energy, then it must be absorbed by the surroundings, which in this case might be air molecules. So that energy cannot simply disappear. And conversely, if the chemical reaction is absorbing energy, then that energy must have come from the surroundings. So either way, if I were to add up all of the energy in my system or the chemical reaction and the surroundings, it's going to be exactly the same before as it is afterwards. Overall, energy is conserved. Let's now briefly summarize the key points from this video. Firstly, the law of the conservation of mass states that mass is conserved during a chemical reaction. And this means that the total mass of reactants must equal the total mass of products during a chemical reaction. Secondly, the law of the conservation of energy states that energy is conserved during a chemical reaction. And this means that the total energy in the universe is the same before and after a chemical reaction. And that's it. Hopefully, this video was of some help.